Hi guys, this is Dr. G here, and in this video we will talk about metals with variable charge and their impact on ionic compounds. Please note that in a previous lesson we already learned about common cations and anions found in ionic compounds, and also we learned how to figure out their charge by looking at the group number, right? And also we learned how to write simple chemical formulas for ionic compounds, and we learned how to name them. So in this video we are going to specifically talk about certain metals in the periodic table that could contain more than one stable cation. Okay, certain metals in the periodic table can contain more than one stable cation. As an example, iron. Okay, iron is a transition metal, and iron actually have two stable cations that are commonly found in nature. So these two cations are Fe2 plus and Fe3 plus. Okay, so similar to iron, okay, there are many other metals that have more than one stable cation. Okay, and most of these metals are actually transition metals. Okay, most of these metals are transition metals, but it is not limited to transition metals. Certain p block metals, okay, certain p block metals can also show more than one stable cation. Okay, and of course there are common exceptions, especially zinc only has a 2 plus charge. Okay, and silver metal only has a Ag plus ion, and then cadmium only has cadmium 2 plus ion. Okay, so of course just because the metal is a transition metal doesn't mean that it is going to have more than one stable cation. Okay, it doesn't mean that it is going to have more than one transition, more than one stable cation. There are exceptions, and I highly recommend that you guys remember these exceptions. Okay, I highly recommend that you guys remember these exceptions. So we already learned that if the cation comes from group 1a or group 2a, they only have one charge. Okay, one charge. If it is in group 1a, it will be a plus 1 charge. If the metal cation is from group 2a, it will always be a plus 2 charge. And aluminium has a plus 3 charge. But certain metals, okay, even from the D block, okay, even from the D block could have more than one stable cation. The common examples are tin, lead, and bismuth. Okay, all three of these D block metals have more than one stable cation. And of course there are many transition metals with more than one stable cation. Okay, there are many transition metals with more than one stable cation. So I'm not asking you to remember all these cations right now, but I mean it is important that at least you have a commonality, okay, for these cations. Okay, and when you are naming these cations, okay, you also use the charge. Okay, so as an example, if you want to name bismuth 3 plus cation, you know bismuth has more than one stable cation. So when you are naming them, you have to distinguish between bismuth 3 plus and bismuth 5 plus, right? So when a metal has more than one stable cation, you always have to distinguish the two. So to distinguish the two, what we do is when naming them, we write the element name, and then we also use the charge. Okay, we write the charge using Roman numerals within brackets. Okay, another example for gold. Okay, gold has two stable cations. Okay, gold has two stable cations, and then gold plus 1, okay, is known as gold 1. Okay, and the other cation is called gold 3. Okay, so you write the charge of the cation using Roman numerals, and you use it after the name of the element within brackets. Okay, that is something important to remember. All right, so next up we are going to learn how to determine the variable charge of a cation. Okay, next up is the determination of variable charge of a cation. Or in other words, if you already know the chemical formula, let's say MnCl2. Okay, here is a chemical formula for an ionic compound that contains a manganese and a chloride. Okay, so if you already know the chemical formula, how do you determine the charge of your cation? So that is what we are going to learn next. Okay, so already we learned that when we are writing chemical formulas for ionic compounds, we make sure that the total positive charges are going to be equal to the total number of negative charges, right? Or in other words, the overall charge of an ionic compound is 0. So therefore, MnCl2 should also have an overall charge of 0, which means if you separate the cations from the anions, okay, cations gives you the positive charge, anions gives you a negative charge. So if you separate the cations from anions, you know that the charge generated by cations will be equal and opposite to the charge generated by the anions. So when it comes to anions, you have two chlorides. We already know the charge on chloride, okay, which is -1. So you have two chlorides, which means this side has a overall charge of -2, and this -2 should be equal and opposite to the cation charge, which is +2, okay. So it should be equal and opposite to the cation charge. So from the cation side, where you only have one manganese ion, okay, and we don't know the charge of manganese because manganese is a metal with a variable charge. So you want to figure out the charge of manganese, okay. So you want to figure out that, and we know that this manganese will provide only a +2 charge because it should be equal and opposite to the negative side, right? So you have only one manganese, so the manganese charge will be what? Manganese charge will be +2, okay. You have one manganese, okay, you have one manganese. This is how you do the math if you want to do it in detail, okay. So you have one manganese, and we don't know the charge, but it will be equal to +2, okay, and 1 times x is +2, and of course x is +2. All right, so the manganese charge will be +2, Mn2 plus, okay. So this is the charge of the cation that is involved in this formula, okay, in this formula. So it is a manganese 2 plus. So let's learn how to write the name of this ionic compound, okay. So usually when you are naming ionic compounds, you write the metal cation name, you leave a space, and you write the anion name, right? But when you have a metal with a variable charge, you write the metal cation name, okay. In this case it is manganese. This is the metal cation name, and then within brackets you have to write the charge. Why? Because it has a variable charge. Manganese could have multiple charges, so you have to identify the charge, which is +2, and then chloride, and then chloride, okay. All right, so let's do another example. Let's do Fe2O3. Okay, so you have a ionic compound between a cation from iron and then oxide. Okay, so the first thing that you need to do is you need to figure out the cation, okay, or the charge of the cation, okay. Figure out the cation charge, and second you need to write the name. Okay, so these are the two things that you need to do. Okay, so let's first separate the cation side from the anion side. Okay, so I'm going to draw a line. And then this will be your cation side. This will be your anion side. And please note that iron is a metal with a with more than one stable cation. It could be Fe2 plus or Fe3 plus. So we already know that we have to figure out the charge because no one can memorize the charge for this compound. Okay. All right. So in the anion side, you have three oxides. In the anion side, you have three oxides. In the cation side, let's use a different color. In the cation side, you have two ion cations. Okay, so we don't know the charge, so let's call it A. Okay, let's call it A. All right, so you have 2A from the cation side. This will be the charge, and then on the anion side, you have 3 times 2, which is a -6. Okay, -6. So if this is -6, you know that the cation side should be equal and opposite. So cation side should be +6. Okay, cation side should be +6. So 2A is going to be equal to +6, right? A is the charge of the ion cation. Okay, so you have two of these ions, so therefore 2A equals +6. A equals what? +3. So that is the charge of your ion. Okay, so that is Fe3 plus. Okay, so we already figured out the charge of the ion. Okay, and now let's write the formula. Let's write the name. Okay, so this will be ion and then we have to write the charge because iron is a metal with a variable charge. So this is iron 3 and then oxide. All right, so let's do another one. Okay, let's do another one. So let's try Bi2 S5. Okay, S5. Here's another example. So let's see if you could do this quickly. Okay, so when writing chemical formulas, how did you write chemical formulas? Okay, so you take the metal cation and you take the non-metal anion and you write the metal first. And then you swap the charges. You basically swap the charges, and then metal gets the charge on the non-metal without the sign, of course, and you put it as a subscript, and then you write the non-metal, and then non-metal gets the charge of the metal without the sign, right? So you basically know what these numbers are. They were previously on metals, right? So rather than doing all this math, okay, so your head knows that this N is the charge of the non-metal, this M is the charge of the metal, right? Which means this 5 should be the charge of the metal, right? This 5 should be the charge of the metal, so it will be Bi5 plus, right? And then this 2 right here, it should be the charge of the non-metal, right? So it is a sulfide. We already know that because S2 minus is the charge of sulfide, right? So you don't really have to do all the math. You can easily figure it out by basically de-swapping the charges. Okay, when you are writing the chemical formula, you swap the charges and put them as subscripts. So by looking at these subscripts, you kind of know the charge. Okay, you kind of know the charge of the cation. So you can do that. It is a good shortcut, but you have to be a little bit cautious. Okay, it's a good shortcut, but sometimes you have to be a little bit cautious. Okay, but now we know that is our metal. So let's write the name of this ionic compound. So you have a bismuth, and the charge is 5, and then sulfide. So that is the name of the ionic compound. But this reverse swapping, okay, could be a little bit tricky. Especially if you have a compound like this. Okay, let's say PbO. PbO. Here is an example. Okay, see if you could calculate the charge for lead. See if you could calculate the charge for lead. Okay, I will give you a second. See if you could calculate the charge of lead. All right, so if you did the calculation method, you will figure out that, okay, let's do the long way first. Let's do the long way first. Okay, so if this will be the cation side, this will be the anion side. You have only one oxide, so 1 times O2 minus. Okay, you have one lead. We don't know the charge. Let's call it X. Let's call it X. So this is the charge. Okay, so 1 times minus 2 is minus 2. So the negative charge, the total negative charges you have from the anion is minus 2. So it should be equal and opposite. It should be equal and opposite to the cation charge, right? Which is plus 2. All right, so this plus 2 is coming from what? It is coming from only one lead. Only one lead cation. Okay, so the lead charge will be Pb2 plus. Okay, Pb2 plus. So that is what you have. And we also learned that we can use a shortcut, right? We can basically de-swap it. We can basically de-swap it. So it is PbO. Okay. But if you are like using this shortcut, I mean, you will realize that this is a 1. Okay. So it will be 1 and 1. Okay. Even though we don't write it, it is 1, 1, 1 and 1. So you might think that, okay, if it is 1, then the lead charge will be plus 1, right? Plus 1. So this should be correct, and but it doesn't match the previous answer, which is Pb2 plus. Why? Because if you do the same, then the oxide charge will be a minus 1. The oxide charge will be a minus 1, which is not correct. Oxide is not minus 1, it is actually minus 2. Minus 2. Okay, so here is the key, guys. Here is the key. So if you see an ionic compound, and then you definitely know the oxide charge, which is 2, right? If you don't see 2, that means it is cancelled off, right? So both should be 2, and then you cancel 2 to 2, and then you write it as PbO. Okay, so if you don't see the charge of the anion directly next to the metal, don't just de-swap it and think that, okay, it is plus 1. That is wrong. Okay, don't do that. That is wrong. Instead, you have to, like, get a 2 in next to Pb. Why? Because that is the charge of the oxide. So to do that, you have to multiply the whole thing. You have to multiply the whole thing by 2, right? The whole thing by 2. So when you do that, oxygen also gets a 2. Oxygen also gets a 2, and that will be the charge of lead. That will be the charge of lead, Pb2 plus. All right. So this is tricky. So if you are planning on using the de-swapping method, it could be tricky. Okay, it could be tricky. Here's another example. Let's do PbO2. Let's use something else. Let's do chromium oxide, Cr2O3. Okay, so what is the charge of chromium? And here's the key, guys. You know that oxide is a 2 minus, right? Oxide is a 2 minus ion. Oxide is 2 minus, and you see this 2 right here. That means this 3 should be the charge of chromium. So this is a chromium 3 plus. This is a chromium 3 plus. It is a chromium 3 plus. Okay, so the name of this compound will be chromium 3 oxide. Okay, so I hope that you guys understand how to figure out the charge of the cation if the cation is made up of a metal with a variable charge, and then I hope that you know how to name these ionic compounds. So let me give you a few examples, and you can try them by yourself. Okay, and then you should be able to perfect your craft. Okay, let's see if you could complete these 9 examples. Okay, so be careful. Okay, so what I want you to do is I want you to figure out the charge of the cation, and then write the name of the compound. Okay, write the name of the ionic compound. So you might want to be extra careful when you're doing number 7, and number 9. Be extra careful when you're doing number 7 and number 9. Alright, so you might want to pause the video and then figure out the charge and the name. Okay, so first up we have nickel chloride. Nickel chloride. Okay, so in here, chloride is what? Chloride is a, let me use a different color so that you will not be confused. Okay, so you have nickel chloride, and chloride is a -1 charge. So I mean, it matches with the number you have next to the nickel, which is no number, that means 1, right? So it matches with the charge. Okay, it matches with the charge, so that is good. That means this 2 comes from nickel, right? So this is a nickel 2 plus. So this is a nickel 2 plus. This is a nickel 2 plus. So the name will be what? The name will be nickel 2 chloride. Let's do the next one. Okay, let's do the next one. It has an oxide. So oxide is a -2. Okay, and the charge of oxide matches the number that you have next to bismuth, which means this number 3 should be the number for bismuth, right? So it will be Bi3 plus. So you have a bismuth 3 plus sign. So the name of this compound will be bismuth 3 oxide. Let's do the third one. Okay, so you have a CuO, and we know that oxide is O2 minus. Okay, O2 minus, and this O2 minus has a -2 charge, but copper has no number. That means it is a 1, right? So it is half of 2. 1 is half of 2, right? That means, when getting the lowest ratio for copper and oxygen, we have divided it by 2. So it should be ideally 2 and 2. But I mean, we cancel them because they are the same number. Okay, so the copper charge should be what? The copper charge should also be 2. So you have a Cu2 plus ion. Okay, remember, always match the charge of the oxide with this number. If it is not matching, that means, it has cancelled off. Okay, so Cu2 plus. So what you have here is copper 2 oxide. Alright, so I'm going to quickly complete 4, 5 and 6 and then post the names. Okay, so you can check them. Fe2S3 is iron 3 sulfide. PbO2 is lead 4 oxide. So pay attention to the number 4 and see if you could get that. Okay, the key here is that you don't see a number next to Pb, right? But oxide is what? Oxide is O2 minus. So you should have a number 2. You don't have it. That means, you have to multiply it by 2. So this 2 becomes 4. Okay. Cobalt 2 chloride. Okay. So those are the names for 4, 5 and 6. Let's try number 7. This is tricky. Okay. Pay attention. Okay. So the name is silver chloride. So some people are like, okay, that's not true because I wrote silver 1 chloride in my answer, right? That is not correct. Here's the thing. Silver is unique. Silver, cadmium and zinc are unique. Why? Because even though they are transition metals, they only have one stable cation. So if you have only one stable cation, everyone knows that it is Ag+. So there is no point of writing the charge because everyone knows it. So it is right. It is like naming a regular ionic compound like sodium chloride. Don't write the charge. Don't write the charge because everyone knows that silver only has a +1 charge. So do not write the charge. Okay, that is important. And next one is very straightforward. Nickel is a +2. So this will be nickel 2 oxide. All right, so number 9 is tricky. Why? Because iodide is the anion that you have. It is a minus 1. It is a minus 1. But here you have a 2 next to, here you have a 2 next to mercury. How did you get that? I mean, you have multiplied the charge by 2. So this number 2 should also have been multiplied by 2. So Hg should be what? Plus 1. Hg should be plus 1. Why? Because if this number is twice as minus 1, then this number should also be twice as the charge of the mercury. So you have a mercury 1 cation, mercury 1 cation. So this is what? Mercury 1 iodide. Here's something to remember. So we usually don't do this, right? If it is 1, we usually write like Hgi, right? But in this case, mercury ion do something you could say weird. Okay, why? Because mercury ion forms an ion pair. Okay, mercury ion tend to form an ion pair called Hg22 plus. Okay, so rather than staying as a Hg plus, mercury stays as Hg2 plus, Hg22 plus. Okay, that is why you see we are using 2 iodides. That is why you see that we are using 2 iodides. Okay, that is why you are seeing that we use 2 iodides for this formula. Okay, that is why we are using 2 iodides for this formula. All right, so that is something to remember. That is an exception, but still, you should have figured it out from the numbers. Okay, all right, with that I'm going to conclude this lesson. This is an important one. Okay, so I hope that you guys will do more practice questions. I have plenty of examples in your lecture note, but let me know if you have any questions. Okay, you guys have a good one. Take care.